Good afternoon, good evening, and good morning. And thank you for joining us here at the Royal Institution in London. I'm delighted to welcome you to the launch of Ocean Census, the largest programme in history to discover ocean life. I'm Emily Penn, and I will be your host for the next 1 hour and 15 minutes. It feels very appropriate that we are here at the Royal Institution for the launch of Ocean Census. This is the home of science here in the UK, and the scientific home of Michael Faraday, 15 Nobel Prize winners, and countless other geniuses who all worked here and came into this hall to share their scientific breakthroughs with the world. Today, we hope to inspire you with the ambition and vision of Ocean Census, and we hope that you will leave with 3 things. Firstly, that the urgent discovery and protection of ocean life is vital for the future of our planet and humankind. Secondly, Ocean Census is an open alliance of partners from government, science, business, media, and civil society, coming together to address this global challenge. And thirdly, we hope that each of you will want to play a part. We can't do this without you. And so, to the rundown for today. We're going to first hear from our distinguished speakers, from the Nippon Foundation and Necton, and from Japan's ambassador to the UK. And this will be followed by a panel of expert scientists. We will then have some time for questions from the audience here in the lecture theatre. And before I ask our first speaker to join me, we would like to show you a short film to prepare us for our extraordinary journey ahead.
For millennia, we have sought answers to our existence. But we've been looking up when we needed to look down. Ocean life makes all life on Earth possible. It gives us air to breathe, feeds billions, regulates our climate, and is our medicine cabinet. The ocean gives us the code to life on Earth. 2 million different species exist below, and yet we've discovered only a fraction. We can't protect what we don't know exists. But that is changing fast. Technology now allows us to explore the furthest reaches of the ocean, from the surface to the crushing depths, more than 10,000 meters below. Combining revolutions in imaging, sequencing, and machine learning, which enable the greatest ever discovery of ocean life at speed and at scale, transforming our knowledge of life on Earth. Let's take the next giant leap together to discover life, discover knowledge, and discover our future. Ocean Census. Join the mission.
Please join me in welcoming our first keynote speakers for some introductory remarks. The chairmen of the 2 founding partners of Ocean Census, Yohei Sasakawa from the Nippon Foundation and Rupert Gray from Necton, and His Excellency Ambassador Hayashi, Japan's ambassador to the UK. And so first of all, Chairman Sasakawa, if you'd like to come to the podium, and the floor is yours.
Thank you. Your Excellency, Mr. Hajime Hayashi, Japanese Ambassador, Mr. Rupert Gray, Chair of the Necton Foundation, and distinguished participant, it gives me great pleasure that today, together with the Necton Foundation, we are ready to embark on an ambitious mission to protect the ocean environment by unlocking the mysteries of the marine ecosystem. We are now setting out into romantic adventure filled with passion and dreams. Since our founding, the Nippon Foundation has made great effort through diverse initiatives to open the way for a healthy ocean and to pass it on to future generations. Our work includes many exciting projects, such as nurturing 1,600 ocean professionals from 150 countries, opening up the unexplored Arctic sea route, completing the mapping of the global ocean floor, and developing unmanned autonomous vessels. I myself reading Jules Verne's 20,000 Leagues Under the Sea as a young boy. I was captivated by the wonders of the ocean, the great seabed adventure, the battle with the gigantic octopus, food I could never imagine. They are all a surprising shock to me. Particular encounters with different marine life triggered my strong curiosity toward the undiscovered ocean. My childhood desire to want to learn more about the unknown ocean and to unravel the mysteries of the ocean has grown even stronger today for an 84-year-old young boy. Despite the amazing speed with which science and technology have advanced, and we have 100% knowledge of the tomography of Mars, we still know very little about the Mother Ocean that nurtures all living things. As for marine organisms, it is said that we only know around 10% in total. To discover these unknown marine organisms hidden in the ocean, we present to you here today ocean sensors. May I now have your attention and watch the video you all know that long time ago. There was a legendary sea monster called Kraken. There is a theory that it is in fact a giant squid. This giant squid is close to 10 meters long and lives at a depth of 1,000 meters in the sea. Japan Broadcasting Corporation successfully filmed it. The following video shows a Yokozuna slughead taken by Jamstick. This is a new species discovered in Japan a few years ago. It is a deep sea hunter that lives at 2,000 meters in the deep sea. Next is a snail called Conus magnus, which was discovered nearly 300 years ago. The recent study found that its venom, when used as a painkiller, is 1,000% more potent than morphine. As we can see, through the discovery of living beings, that were no more than a fantasy, or these already discovered, of which new species and their characteristics have the potential to make our life more enriching. We sincerely hope that the Ocean Census Project will bring about similar exciting discoveries. The characteristic of this project is that it not only explores unknown marine organisms, but analyzes and manages the vast amount of data collected through exploration and to disseminate the information to the entire world. We hope that in doing so, it will lead to the preservation of biodiversity and ocean environment. As you know, the ocean covers 70% of the Earth. Although there are close to 200 separate countries, there is only one single ocean. And it is a common asset of humankind. Should the ocean be the fundamental element for the co-prosperity of humankind, I cannot but wish that this project will be a catalyst to the further advancement of humankind. Such an ambitious project, full of dreams and potential, cannot be accomplished by the Nippon Foundation and the Nekton Foundation alone. I'd like to work in collaboration with the Ocean Research Institute around the world and all present here today to unravel the mysteries of the ocean together. Once again, I am delighted that we have been able to celebrate the launch of our Ocean Census project with you. Thank you very much.
Thank you very much, Chairman Sasakawa. And I would now like to invite Chairman Gray.
Konnichiwa, Your Excellency, and Chairman Sasakawa. And to those of us who have a lesser command of Japanese, ladies and gentlemen, welcome as Chairman of Nekton. Chairman Sasakawa, thank you for your kind words. And I'm so pleased you paid homage to Jules Verne, who was one of the great authors of my childhood. My own conversion was less dramatic, but it had a similar impact. Sleeping in the bow net below the spar of a square-rigged barkentine crossing the Pacific in 1979, which I did every night if I could, I found myself in company with the Pacific blue-nosed dolphins dancing about in the phosphorescence below. Where did they come from, I wondered, and where were they going? And it seems now, for the first time, I'm about to find out. You also said, Chairman Sasakawa, with great elegance, that today we begin a vitally important journey to discover what lies beneath the octopi and the dolphins. And we are here to learn from what we find. We're following in the footsteps of those who have done so much for ocean field science since Pickard and Walsh descended to the bottom of the Mariana Trench some 63 years ago. And our collaboration has the advantage that they didn't have of the extraordinary technology that we have available today. Marine scientists now say they are now in broad agreement that the proportion of species in the ocean yet to be identified is about 90%. The ocean holds 4 billion years of our evolutionary heritage. And this priceless asset is now, as we all know, at grave risk. It is a significant failure in our generation's stewardship of the planet to know so little about so much. Ocean Census' objective is to redeem that failure. If, between us all, we fail in the task, humans will die. And the ocean, of course, will survive. Discovery is one thing, and exciting to be a part of, to say the least of it. But to learn from these discoveries and to share that learning with the world is equally crucial. We at Necton and at the Nippon Foundation, and many of you gathered here today, Oxford, the Natural History Museum, Monaco, Navigator, the Schmidt Ocean Institute, and RevOcean, and many others, are joining forces to do exactly that. Chairman Sasakawa, and indeed Your Excellency, there is a particular bond between us that I want to emphasize today. We both belong to and are formed by island nations. It's very striking that this initiative Ocean Census, which we have created together, springs from two maritime nations who depend on and have a long-standing love affair with the ocean. And in both cases, the ocean is inexorably linked to the heart of our respective national lives. And it is island nations who are on the front line of the problems we are about to face. In this, and this is important, we stand beside the other island nations of the world, most of whom are in the global south. And that bond is a crucial part of our approach at Necton and Ocean Census. For we're facing into the wind, with the storms of climate change and biodiversity crisis upon us, and projected to worsen. As of now, only 17% of land and 8% of the world's oceans are protected, a number that needs to significantly improve, and fast. I'm very glad to say that I'm optimistic about this, as we all are at Necton and Ocean Census. The conversations I heard this morning before we all gathered here amongst some of the world's leading scientists in the field gave me great cause for hope, and I found very, very heartening. And I'm also glad to say that advances are being made, I was going to say by the lawyers, but that may be unfair to leave people out, in the regulation of the oceans. The 2022 Montreal Biodiversity Conference made the decision to protect 30% of our planet for the conservation of life by 2030. The United Nations Biodiversity Beyond National Jurisdiction Treaty was agreed in March this year, yet to be ratified. These will provide us with a legal framework to establish protected areas in the high seas across nearly half of our planet. It demonstrates very clearly that multilateralism has still got a future, and we're going to need that. The discoveries which Ocean Census and others will make will enable those in government to regulate strictly the manner in which the ocean is protected and its resources managed to best advantage. I use the word enable. It will enable them, but it does not mean it's going to be certain that it will happen. That is for nation states and governments and international agencies. I pray they are up to the task. As Sir David King, formerly the government's chief scientific advisor, who may be in the audience, I haven't yet seen him this morning, has very recently said, and I quote, "Now more than ever, there is an obvious need for a full assessment of the risks of climate change to be given to the heads of government and their advisors. And yet this is still missing. It is intended that Ocean Census will contribute to that assessment." Chairman Sasakawa, the opportunity to work with your foundation towards these objectives is transformative. I am well aware, as is Necton's team of high-level scientists and persons of high action, of the Nippon Foundation's long-term commitment to and support of the stewardship of the world's ocean. Your reputation goes before you, and we are glad, proud, and honored to join forces with you in that stewardship. Thank you.
Thank you, Chairman Gray. And I would now like to invite Your Excellency, Ambassador Hayashi, to take the podium.
Thank you very much for a kind introduction. Chairman Sasakawa, Chairman Gray, and truly distinguished guests, both gathering here at the prestigious Royal Institution and online. It is my great pleasure to say just few words this morning here in UK, particularly after a series of quite impressive, very persuasive remarks by two chairmen. But I would like to say a few words as we celebrate the launch of this remarkable new initiative, Ocean Census, jointly organized by the Nippon Foundation and the Necton Foundation, which will certainly shed new light on the world of marine ecosystems. I would like to underline that Japan and the UK have strengthened our friendship throughout numerous collaborative projects, not only in terms of diplomatic relations and business connections, but also across a wide variety of fields, including academia, art, culture, and education. Some of these collaborations have been supported by top-class experts and stakeholders from both countries. They have contributed to the enhancement of knowledge, welfare, and quality of life for people around the world, and has gone beyond the scope of bilateral partnership. In this regard, I would like to express my heartfelt appreciation to Dr. Sasakawa and the Nippon Foundation for his and its continuous commitment to social innovation through the efforts to support many important projects. As many of us are well aware, the current decade, the years of 2021 to 2030, is the United Nations Decade of Ocean Science for Sustainable Development. I believe that both Japan and the UK, as the two maritime nations committed to the future of oceans and committed to the protection of nature and biodiversity, both on land and in ocean, should and can take the lead in this field of the world. Therefore, I am particularly delighted that the collaborative projects by two important foundations, by the Nippon Foundation and Necton Foundation, namely Ocean Census, has been launched as a landmark initiative contributing to a sustainable future for the world's oceans. This project has set an ambitious target to discover more than 4,600 of new species of maritime
massive scientific effort to find more species at speed and at scale to protect them. And that call's been answered by philanthropists at the Nippon Foundation, which works to solve global issues through social innovation, partnering with Necton, a British marine research institute. The Foundation's chairman, Yohei Sasakawa, believes that inspiring the public is fundamental to success, and that science has to join forces with business and civil society to make real change happen. The programme, called Ocean Census, will be the largest ever attempted. The target is ambitious, finding at least 100,000 new species in a decade. It will be headquartered here in Oxford, where the University Museum of Natural History is home to prized collections from previous eras of exploration. How much kind of don't we know yet about what's in the ocean?
Well, we've only described about 10% of species in the ocean.
So there's a hell of a lot that's waiting to be discovered.
Yeah, absolutely. I mean, 90% of biodiversity is, we just haven't described, in many cases, not even seen.
Professor Alex Rogers, a veteran of deep sea research, is the lead scientist.
We are in a race against time. We have global warming, the ocean's losing oxygen, it's acidifying, and as a result, we're losing species. If that process continues, then we will face another major extinction in the ocean, and we will lose great swathes of the tree of life, essentially.
These shelves, full of specimens brought to Oxford by early explorers, all have tales to tell.
We've got specimens here from the Challenger expedition, which are 150 years old. And each of these are the first time examples of these sponges were ever seen.
It's amazing seeing the rich legacy of discoveries in the oceans in the past few centuries. These were found by Charles Darwin. The problem is that the process of describing new species hasn't really picked up speed since his day, but that's about to change. Ocean Census will launch a series of expeditions to search for marine life, partnering with philanthropic, government and commercial fleets. Scientists on board will deploy some of the world's most advanced technologies, submersibles, remotely operated vehicles and divers, as they collect samples in the most extreme environments. And they'll be delivered to research centres like this one, the Wellcome Sanger Institute near Cambridge in the UK. Researchers will extract the DNA and try to establish if whatever's been found really is a new species. It's about creating a bigger picture of the tree of life.
Nowadays, we can do this in a few days to a few weeks, just by looking and comparing different pieces of DNA.
It's the ability to analyse DNA that's transforming the way this work is done. Scientists will build up a picture of what's living in the ocean and how it all fits together faster than ever before. Darwin would be astounded. And the project isn't a one-off. The aim is to forge a global partnership and to open it to everyone. From children swimming in the shallows to leisure divers who could all become citizen scientists looking for marine life before it's lost forever.
The question is, how can we actually then protect our marine environment for our children?
It's kind of like a race. So we're racing against something that's been destroyed, which we don't even know what's been destroyed.
If we're going to make changes to global warming, you need more than just a bit of science looking at what's in the sea. You've got to convince people to do something about it.
Taking the public on a voyage of discovery to see the abundance of marine life and how it's threatened is part of the philosophy of the Ocean Census programme.
We need people to fall in love with the majesty and the wonder of ocean life if we're going to have any chance of protecting it. We also need to find ways for people from all walks of life to be involved. And that is going to be vital to the success of the programme.
For low-lying countries, more vulnerable than most to the climate crisis, data from this project will be invaluable, generating new insights to help protect the ocean.
There's so much of the ocean that is undiscovered in terms of its species richness and diversity. And the people who will be out there capturing and collecting these organisms and describing them and seeing them for the first time and preserving them in such a way that they can come here and we can generate that baseline understanding of their genomes, and forevermore there's a record of what that organism's DNA looked like. And this will be really important as we move forward to try to understand what is out there, and are we doing a good job at protecting it.
The ocean is the cradle of evolution. It's a source of food, of oxygen, and of cures for diseases. We humans all depend on it. And every new species found is another piece in the puzzle of life itself.
Now, please join me by welcoming our science panel. Professor Alex Rogers, Dr. Jyotika Vemani, and Dr. Hiromi Watanabe. Please join us here on stage. Thank you. So, coming to you first, if I may, Professor Rogers. You are the lead architect of the scientific programme and the scientific director of Ocean Census. And we've heard a little already from David on the urgent need for Ocean Census. And please could you elaborate a little bit on why we need to launch this initiative right now?
Well, we currently face two crises in the ocean. There's the climate crisis, but also a biodiversity crisis. If we look at coral reefs, we've lost about half of them since 1870. For mangrove forests and salt marshes, the figures are between 40 and 60%. And of course, these are some of our richest habitats in terms of species. But even some of our most iconic species, if we think about things like oceanic sharks and rays, they've undergone a decline of about 71% over recent decades. And in fact, 3/4 of those oceanic sharks and rays are now threatened with extinction. So the clock really is ticking, and we are in a race against time to try and document the diversity in the ocean, not just to kind of record it, but also to try and actually change this trajectory of decline to one of recovery.
Thank you. And to Dr. Vemani, I mean, firstly, thank you for the wonderful clips that we saw there from the Schmidt Ocean Institute in the film. Now, the Schmidt Ocean Institute is a major philanthropic marine research organisation and one of the major partners of Ocean Census. And you've recently launched a new vessel, Fulka 2, and developing and deploying advanced technology is really at the heart of what you do. So please tell us, what technologies are you most excited to be deploying on your expeditions that will help discover ocean life at speed and at scale?
I love this question. So yes, we did recently launch Falcor 2. It's on its second cruise now, and we have on board ROV Sebastian, which was in that film. That's an ROV that can go down to 4,500 meters, and it's got 4K high-resolution video camera and photography equipment on board. But in addition to visual images of creatures underwater, we also test prototype technologies, and we can add those to that ROV to gather samples. And so I'm just going to highlight a couple of them, which is really exciting, I think. There is one called Deep PIV, which is essentially a laser and you can scan gelatinous creatures like jellyfish. So it's really hard to bring those back to the surface. You can now look at them in the water column and see what the morphology of those creatures are and study them in situ. So that's one really exciting piece of technology coming out of Mbari. And the other one, another example, is called Iris, also out of Mbari. And that's it's a camera system as well, but it shows you where the most movement happens for a creature. So it's kind of like a heat map. And that gives you an idea of how they move and where their stress points are. And so it really, and that again is also in situ, in the water column. You don't need to take creatures out. So I think what we're moving towards is this place where we can actually perhaps even do taxonomic identification eventually in the water column instead of bringing everything back to land. And that's really exciting because that will make things move a lot faster. And you combine that with eDNA, which is environmental DNA, and that then scales up. You know, you were talking about scaling up the ocean.
Mm-hmm.
That really scales up how you can see the quantity of creatures in the water, the diversity, invasive species. So anyway, a lot is happening on the technology front, and we're really excited to help support the testing of that on board.
Great, it all sounds fantastic. Now, to Dr. Watanabe, welcome. So Ocean Census is an open alliance of partners, and they're all coming together on this global effort. Now, you're an esteemed taxonomist with the Japan Agency for Marine Earth Science and Technology, otherwise known as JAMSTEC. What scientific organisations and institutions would you like to see participating, and where can they all contribute the most?
I think it is great if many of deep sea, the people who are interested in deep sea will be involved in this project. So as Alex said, the coral reef may be the very important and fascinating environment in the ocean, among the ocean environment, but the deep sea comprises more than the 90% of ocean. And yeah, I'm a deep sea biologist in JAMSTEC, and JAMSTEC, we operate many deep sea research facilities in the Western Pacific. And yeah, JAMSTEC will be, I hope JAMSTEC will be supported to operate this kind of facility to support the discovery of deep sea marine life in the Pacific area.
It's great to have so many organisations.
May I add one more
Absolutely.
thing? Yeah, and many people, as many people know, there are many existing deep sea biology network of deep sea biology scientists. And if I also hope the Ocean Census will support the networking of this kind of support this kind of network, including the UN Decade of Ocean Science Program Challenger 150 and the Deep Sea Biology, Deep Ocean Stewardship Initiative (DOSI), and of course Deep Sea Biology Society, to be more inclusive and empower the networking.
Great, lots of opportunities to contribute. Thank you. And back to you, Professor Rogers. What does success look like for you?
Wow. In the kind of, we plan for the next 10 years really in this project. I would hope by the end of that time we will have made some, incredible scientific discoveries, maybe completely new ecosystems, new communities of life. I would hope that Ocean Census has become an international network of scientists who are interested in the biodiversity of the ocean, all working in one direction to accelerate the discovery of life in the ocean. As Hiromi said, programs like Challenger 150 and the Deep Ocean Stewardship Initiative, but everybody heading in that same direction, producing data that contributes to human knowledge. As Geotica referred to, success would also be being able to harness all of these new technologies to really accelerate our ability to discover and describe the life in the broader ocean. I mean, take one example, pelagic, gelatinous animals, things like jellyfish. I know from personal experience that using conventional technology, which is basically trawls, you end up with just one large bucket of slime at the end of a sampling event. And to actually deploy some of these technologies which can, image these fantastically delicate, very beautiful but complex organisms underwater is really a new way to understand those animals, which now make up communities which we're realising are very important in things like the carbon cycle. And finally, to really be able to accelerate our rate of species discovery by tenfold, or who knows, even more by the end of the programme.
And what's that ultimate goal? 10 years from now, we've documented it all.
Yeah.
What does success look like at the end?
We won't have documented everything in 10 years, but what I do hope is that we have completely revolutionised our understanding of the distribution of life in the ocean. And I'll give you one example of where some of that our work is heading at the moment. Ever since I was an undergraduate, we were told, the most biodiverse regions in the ocean are the Indo-Pacific Coral Triangle and the Caribbean. Well, actually, that number 2 spot may be taken by another part of the ocean called the Mozambique Channel. So it lies between Madagascar and East Africa. And that area, we're starting to gain evidence that it is an incredibly species-rich part of the ocean. So it's things like that, defining the distribution of life in the ocean, where the biodiversity hotspots are, where the hotspots of endemism, the places where species occur but don't occur anywhere else. So those types of things are things that I'm really excited about.
It's fascinating. And also to what you said earlier, the role that technology is playing in kind of revolutionising this type of sciences.
Yeah.
It's very exciting.
Absolutely.
Thank you. Dr. Watanabe, so one of the measures of success will also be more taxonomists. And the majority of biodiversity, as we've kind of been hearing, is in low and middle income nations, where there are the least number of taxonomists. So, we know that talent is equally distributed, but often opportunity is not. So how do we inspire more young scientists, including those from diverse backgrounds, to become taxonomists?
I think we have to know the diverse situation before encouraging the young scientists to be a taxonomist, because there are many countries which have no natural history museum like UK or Japan, and it's sometimes difficult to establish their career as a scientist, as a taxonomist without in the country without active history of taxonomy. I'm sorry, I lost some words. And anyway, and I think there is a gap in understanding between public understanding of discovering a new species between public and academic communities. Because so for public, the discovering a new species is sometimes very exciting and fascinating event. But for taxonomists, for academic people, sometimes it become a single paper, and sometimes it make and sometimes not difficult to be get a good evaluation to continue their position or
absolutely
promoting. So if we can fill the gap to empowerment, enhance the taxonomists to more activate in any countries, it may be very good.
That will make a big difference.
Yeah.
Yeah.
And
Thank
you.
you.
I'm sorry, I couldn't explain.
No, that you've done a perfect job there. And perhaps coming to Professor Rogers, sorry. Too many different words and names to remember today. And to Dr. Vamani, do you have any thoughts on how do we get young scientists, really engaged into this field, especially at the moment when it's changing and so exciting and new?
Shall I go first?
Yeah.
Yeah, actually, we it was mentioned before that there's a whole area of the world that's not really as engaged yet, and they really should be. So we have actually, for the next 10 years, committed Falcor 2, which, by the way, is offered at no cost. This full-scale research vessel that's the philanthropy model that we have, is dedicated to the Southern Hemisphere. And so, Alex talked about, actually, number 2 spot for biodiversity might be superseded by this new area that is showing an incredible amount of biodiversity. We don't actually know if number 1, number 2, or number 3 spots really, truly are those, because there is so much more yet to find out. And so taking this there, but giving people around the world that opportunity to go to sea, to try and, to do their research in their own ocean yard, I think that will really engage a lot more people.
Fantastic. Professor Rogers, anything to add?
Yeah. Attracting more people to marine taxonomy and training them in the scientific skills to do that work is just one part of the equation. You have to create actually long-term employment for those people within their countries. And what this means is the ocean census has to kind of build value through the whole kind of biodiversity area for individual nations. So, they have to recognise how valuable that biodiversity is in terms of the services that marine life provides to those countries, whether that's fisheries, whether it's marine biotechnology. There's multiple ways in which the ocean supports us and supports everyone globally. And I think one of the tricky things for us to achieve is going to be building that biodiversity value chain so the people we train in marine biodiversity research are really valued and supported by their countries. And, building this network around ocean census is all part of that. It's not just biodiversity centres in countries like the UK or Japan or the US. It's also building biodiversity centres in low and middle income countries. It's also training the scientists that can actually sample biodiversity in their own countries, whether that be in the Mozambique Channel or elsewhere. It's also enabling those countries to have their own expertise, to have a voice in international fora like the UN. So I think ocean census actually stands to make an enormous contribution to that area. And we've thought very long and hard over the last 2 years we've been planning this project as to how to do that.
Yeah, brilliant. And I think you're absolutely right. If there's no careers at the end of it, then how are we going to get those young people to join? So, yeah, interesting point. Yes.
Yeah, I totally agree with Alex's statement. And yeah, networking is really important. So we need a network to mentoring and international collaboration of young scientists who is working for taxonomy. And I also would like to add to build up their career, build up a skill set to do some more, to enhance their taxonomic research with some cutting edge technologies like to reconstruct the 3D anatomical images using the micro-CT analysis or some genomic analysis like video introduced. Yeah, then they can build up their career not only as a taxonomist, but they could actually work in many fields in biology in the world.
Brilliant. So, Dr. Vamani, seeing is believing. And I know you have programs running to give people that real kind of first-hand experience. And not only scientists, but also artists, fashion designers, journalists, and others who can actually come and join your expeditions. So what kind of experience do they get?
Actually, we've had artists coming out with the scientists for many, many years now, and we have a collection of art. They come out and they are embedded with the science. The reason for doing it that way is not everybody's going to read a science paper. They might go to an art gallery, they might get exposed in other ways. So from there, we've now built up, we're actually partnering with Necton on this, on a program called Ocean Rising. And that is, how do you get the ocean to the global population that's not already interested in the ocean? And that's through culture. And so we've now started, we're talking to the music industry, the fashion industry, sports, on how do you bring this, those amazing images, marine biodiversity, the seascape and the seafloor, how do you bring all of that so that there is a constant background drumbeat for people as they walk around the high streets, as they go to sports events or in gaming, and we bring the ocean that way. So we're bringing those people on board as well so that they also can be inspired, learn about the science, and convey it in their own way to their audience where they have the expertise. It's very exciting.
And it's almost that kind of subliminal messaging, isn't it, that you want to have as you say, as you walk around a city.
And we have a great partner with Necton in doing that.
Great.
So.
Yeah, lots of exciting opportunity there.
Yes.
Whatever your skill set, whatever you do, it's a project to get involved with.
Yes.
Brilliant. So, Dr. Watanabe, I know that the teams have plans to undertake an expedition in Japan. What wonders of your ocean might we see, and why should people really care about what you discover?
And Japan is surrounded by deep ocean, and which seafloor comprise more than 80% of seafloor comprise is the deeper than 1,000 meters, and it is enriched by many kind of geological features, including the abyssal plains, hadal trenches, and seamount chains, volcanic arc, and backcrack basins. Sometimes it accompanying the deep sea hydrothermal vent, and sometimes serpentine-hosted serpentine-hosted seeps. And there are so many fascinating and flourishing animals there, and I hope we can show some new aspect of evolutionary and biodiversity of these curious animals in the coming years, and share this kind of discovery with the global people.
That's fantastic. And what is it about these discoveries that you think people should really care about?
There are so many diversified animal life in deep ocean, and sometimes they live without sunlight, and they fueled by the chemosynthetic primary production. So then there are so many curious formed animals, so we could know the diversified animal life in the ocean. So then it also helps our understanding of diversified life in the global world.
Fantastic. I can't wait to see what you find. Brilliant. So, Professor Rogers, you've spent many hours in submarines and in the deep sea exploring and discovering new species. I think you've actually already alluded to that there's a few stories, that you've probably got to tell from those many hours down there. And as well as, discovering an entire new ecosystem in Maldives last year on the Necton mission. So please share with us, what does it really feel like to be in the deep beneath the waves?
Gosh, well, it's like exploring another planet. I think that's the simplest way to put it. I remember when we were in submersibles off Bermuda, and Bermuda's an island in the middle of the ocean, and underwater you get these very steep cliffs. And I just remember one moment looking up and seeing the other submersible lighting up this huge cliff with its lights, and the submarine was like this big from the distance we were at, and it was, just an absolutely inspirational moment, seeing the scale of the underwater scenery, and seeing the fantastic life forms we were seeing around Bermuda. That was a big moment for me. Another one was we discovered the first deep sea hydrothermal vents in the Southern Ocean. And I never forget the moment we were diving on some of the vents which we'd discovered in a previous cruise. And as the remotely operated vehicle was descending towards the bottom, we suddenly saw in the kind of distant lights what looked like a huge pile of human skulls on the sea floor, but actually turned out to be this heaving mass of just thousands of Yeti crabs. So for those of you who don't know, Yeti crabs are these pale white, almost lobster-like animals which live around hydrothermal vents in some parts of the world. The first one that was discovered had hairy arms, hence the name Yeti crab. Our one had a hairy chest. So we nicknamed that the Hoff crab after David Hasselhoff. But what was remarkable about that trip, it was just discovery after discovery. The atmosphere on board was like being at a football match for a month long. And every single animal we found in those vents was new to science. So that I hope that conveys a little bit of the excitement of doing this type of work.
I think I wasn't expecting crabs to be the answer. Maybe you can tell us about some of the majestic big creatures that you've seen down there.
Yeah, well, we do get, we had some close encounters with tiger sharks in the Maldives, including one which circled the submarine as we were surfacing, and we were frantically radioing up to the swimmer, who's the chap that swims to the submersible to hook it onto the ship, saying there's a really big shark down here. And the radio was coming back, no, you're just pulling our legs. So, no, there really is a big shark down. But fortunately the swimmer was okay, but boy, he crossed that distance in record time, I think, to the submersible.
Oh, brilliant. Well, thank you all so much. It's fantastic to get a little insight to all of your different aspects of this project. We now have 15 minutes, and I would like to open the floor to questions. Anything that you would like to ask our wonderful panel here from the audience that are in the room. I could already see some hands going up, which is fantastic. So yes, if you do raise your hand, and then my colleagues, they'll be around to provide you with a microphone. And when you ask your question, if you could also just say your name, your organisation, and a short question. I think we'd like to start. Nigel, you just had your hand up down here. If we can get a microphone down. One for now.
I can't wait to show the David Shukman film to my grandchildren this weekend. I can already hear their gasps. Nigel Windsor, I come from the citizen science world, so my question is this. How can marine citizen science organizations around the world contribute, join, or become actively involved? What's the practical process of that? Because my teams in Kenya and Oman are really interested in wanting to be part of it.
To getting involved. Dr. Vamani, I think you should take that one.
Actually, I just recently came across a piece of technology which is essentially collecting eDNA, and it is so easy to use that you just throw it in the water, pull it back out, and ship it back. It's in early stages, but I think by next year there'll be a possibility of having many thousands of these available that could be sent around the world. So, and it's I think that's the missing thing. We need technology that's not expensive and super easy to use to get citizen scientists involved. And so this could go to schools, and school children can even start to gather coastal baseline data from all over the world, actually. So that's one way. Yeah, yeah. And I don't know if anyone else has other.
Well, I think one thing to say is that citizen science is often kind of regarded as a sort of amateur activity, but there's a group of citizen scientists in Germany who were actually a group of people who were recording insects in their local park, and it was them that discovered a huge decline in the numbers of insects basically in Europe through their constant recording activities. So citizen science can really give us a much broader geographic scope of sampling. And people are amazingly dedicated to, discovering species and recording what life occurs around them. And I've seen it myself in my own village in Oxfordshire. Necton and Ocean Census are establishing partnerships already with organisations like PADI, the Professional Association of Diving Instructors, to harness that community of 28 million divers to start discovering and recording marine life during their dives. So, these types of partnerships are going to be important, but also enabling citizens to gather data for Ocean Census and actually feed real data into the science, I think is going to be a really exciting way of not just gathering scientific knowledge, but also exciting people about ocean life. Yeah.
Great, thank you. Some fantastic ways to get involved. We have a question just here. We can get a microphone down, thank you.
Thank you. David Cope from Cambridge University. Potentially a very controversial question. From what we've heard, it does seem to me at the end of the day, whatever that means, the sort of figures we've heard imply there's going to be a need for some form of active management. It's not, okay, collecting the data is the first thing to be done. But as I say, the implication is that humanity will need to intervene in some way. Selective breeding, like of coral that is able to calcify in higher pHs. Transplanting of species from one part of the world to another. We know what's happened on land with some of that. But it seemed to me there's a lot of angst, but very little in the way of active discussion of programs. And will this research program explore, maybe in a preliminary way, what some of those intervention programs might be?
Great. Who would like to take that question?
I think, certainly if we just take coral reefs alone, which are probably the most threatened ecosystem on Earth, at the moment as a result of climate impact as a global threat, but also local impacts as well. I think there is really, we're at the beginnings of looking at some of these alternative ways of really improving the resilience of those systems, but also actively restoring them following impacts from, say, a mass coral bleaching event. I would certainly hope that this programme will be able to contribute to that through, well, first of all, documenting what life is there, and that's including the actual reforming corals themselves, not just near the surface, but down to what we call mesophotic reef depths, down to 150 metres. So actually understanding more about those systems, but also through collaborating with people like the Prince Albert of Monaco, the Second Foundation, and the associated institutes there, which have a major research presence in terms of coral reefs, and people like the Sanger Wellcome Institute for genome sequencing, that we actually start to really gather the knowledge that we will need if we start going down the road of genetically modified organisms, for example, to improve the resilience of the corals themselves, or to look at things like transferring corals from regions where you have more extreme environments where they live, places like the Red Sea, for example, to elsewhere in the world. And to really, generate the knowledge that helps us to make those decisions and make sure that those decisions result in good outcomes and not bad outcomes. We're all aware of things like moving rabbits to Australia and the outcomes of that type of activity. But I think, the issue is that in the marine world, we're really at the infancy of things like ecosystem restoration. Tomorrow, I head up to the Arctic to a cruise there, but then we have a workshop at Rev Ocean in Norway looking at how to restore deep water coral reefs, which are not damaged so much by climate change, at least not yet, but certainly have been severely damaged by bottom trawling. And there are already some promising technologies for restoring those sorts of ecosystems. So I would certainly hope that Ocean Census will contribute to those types of solutions to some of the problems that we're seeing manifesting already today.
Yes.
I'd just like to add, the value of Ocean Census is huge in that the faster we at least gather the data, we can at least store it for now if the technology doesn't yet exist, as we head towards not conservation, but restoration. And that might mean bringing back certain species, but without the original DNA and data in the first place stored somewhere, that will be a non-starter. So I think getting that data is a critical part, even if the technology is not yet there, or the bioethics conversations are not yet there.
Great, thank you all. Thank you, David, for that question. Anyone from over this side? Yes. If we get a microphone to this lady here. Thank you.
Thank you very much. I'm very interested also in the global network. So what does the Ocean Census provide to the scientists? There are lots of people all over the world, in museums, at universities, working on eDNA, genetics, genomics, description of species. Do you provide standards? How does the network look like? Does the network have to be established now, or is there already an idea behind? What will you do for the deep sea area where there is such a pressure at the moment and we know so little? We don't have the names of the species. And even if we have the DNA, we don't know what is the function of the species that live there. So how will you help with the project to overcome the the enormous problems we are facing in the Anthropocene, and on our background, how we change that planet.
Who would like to say that? Yeah, would you like to start?
Ocean Census has been designed as an open network, and that network takes several forms. One form is obviously in the biodiversity centres, the Ocean Census biodiversity centres, which will act as centres for not just accumulating samples and doing the work, but also for training people, opening up access to sophisticated facilities that may not be available elsewhere and so on. Then there are going to be what we've called virtual taxonomy networks. And these are going to be based on individual groups of organisms. So, for example, there will be a virtual taxonomy network on mollusks. And the idea there is to gather the community globally that's working on mollusks, get them to agree what standards they want to work towards, and really start to pull everybody together in that same direction in terms of setting those standards and working by them. And this is not just for professional scientists, it's also for the citizen scientist taxonomists. I had a marvellous conversation in Monaco at a meeting earlier this year where it was pointed out to me that the world expert in describing whelks, which are a type of big marine snail, was a bus driver in Brussels. And it's those sorts of people that, you know, although they're doing this in their spare time, are in fact bringing huge expertise to the network to be able to accelerate our discovery of species in the ocean. For them, they may need very little extra resource to do their work, but to have them in a global network really helps to magnify the impact of their work and give them the opportunities to really contribute to the Ocean Census mission. The other area that we've spent a long time thinking about is data and data standards and data interoperability. And the intention is to design a system called the Cyber Biodiversity System, which really helps taxonomists to make sure that we gather and input the right type of data at the right level of standards, to then transmit those data to global databases like the Ocean Biodiversity Information System, and at the same time enable us to access all of that information pretty much as soon as it's entered into the system. And I think that's going to be really important for kind of upping everybody's game and levelling the playing field in terms of the quality of data that we're gathering.
Thank you, Professor Robert. It's a big challenge, I think, you know, but a very important aspect of the project to enable that kind of global work collaboratively. Thank you. So we've got time for one more question. I'm a bit conscious that I've had my back this way. So yeah, perhaps in the middle here. We can. Sorry, I'm picking people that are hardest to reach with the microphone.
Thank you. And Adrian Glover, based at the Natural History Museum. There's a group we run a deep sea research lab here, and it's wonderful. Welcome this initiative greatly. It's fantastic. And I guess I had one sort of jokey comment to the panel, which is, don't ignore the slime. I heard that slime is of course where it's quite likely that you will find the new species and the new antibiotics and the new anti-cancer drugs. So do consider that in our search for the tiger shark. I think you answered that very nicely, Professor Rogers, with your enthusiasm for the deep sea crabs. I just had one, I guess, a comment which you could respond to. With regards to the sort of emphasis on technology, the longevity and power and usefulness of scientific information, I think, is judged really on its quality, its availability, and its usefulness. You know, and technology is there to enable that. You know, it's not the technological work on its own. It's how useful that data is and how good it is and how available it is. And I think that's something that we, and I use we carefully when we become involved in this program, which I hope we will, think about carefully, and how we move from the sort of the technological emphasis to the actually how powerful and the longevity of that data and how available it is. So that was my only comment.
Great, thank you. Perhaps Dr. Bhamani, do you want to take that one?
The connection between technology and data? It was a comment or a question?
Yeah, I think
it was a comment.
I think it was a comment to respond to.
Right? Yes.
So anything you'd like to add on that theme?
Yeah, so I mean, Alex talked about getting things standardized. I know there are other programs that are also looking at marine, bigger programs as well. You mentioned a few. There's Marine Life 2030, there's MBON and OBIS. So a lot is going on under the umbrella of the UN Ocean Decade as well. But the technology, you're absolutely right. You need to have that end stream of the data, kind of like you talked about, knowing where the taxonomist's jobs are going to continue. So I think as technology gets developed, it's going to be really great to have these standards in place. So those who are developing it know ahead of time, this is what our end goal is and where the data is going to go. Not, let's have this new technology, if you build it, everyone will come, but there's got to be that flow through to the end. So I very much agree with your comment of keeping that in line. I don't know if that, I made a question out of it.
Wonderful. Well, thank you all so much. Big thanks to our expert panel here and to all of you for your fantastic questions. And also a big thank you to our earlier speakers, Yohei Sasakawa, to Rupert Gray, and to Your Excellency Ambassador Hayashi. Thank you all for being here today. And for all of you around the world who have joined this broadcast, thank you for tuning in too. We hope that you will all join us on this mission. It requires a colossal global effort, and every one of us has a role to play. Thank you again for joining us. Great. I've been informed that we